In this lesson we're going to look at energy transfer in reactions. So we'll start by saying that chemical reactions always result in some kind of energy being transferred. As I say, all chemical reactions result in energy changes. Now, those energy changes are nearly always in the form of heat. Okay, so we'll write heat down here, but there are some cases, as you well know, where, for example, light will be released and also sound, depending on the type of reaction. But from our point of view, in this unit, we're really dealing with heat energy. So heat energy is always transferred in reactions, and it can be transferred in two ways. It can be released during the reaction, or it can be absorbed during the reaction. So looking at the first case where we've got two substances reacting, they're producing a new substance. Call it green if you want. We're not really interested in the nature of substances in this particular case. What we're interested in is what's going on at the energy level, and in this particular reaction, energy is being released. So heat is given out. Now, so if this reaction were taking place, for example, in a test tube or in a beaker, then what you would see as a result of the heat being given out is that the temperature will rise. So in this particular case, we'll get an increase in temperature. And because heat is being given out during the reaction, this type of reaction is known as an exothermic reaction, where exo is sort of Latin for giving out, or being given out, or going out, and thermic refers to heat. As in thermal, for example. Exothermic, heat being given out. And the other type of reaction that can take place is where heat is absorbed. Okay, so we've got some substance here reacting with another substance, forming a new substance. This time, as the reaction takes place, heat is absorbed. So we'll represent that with arrows like this. Heat is being taken in from the surroundings as the reaction takes place. So, for example, if the reaction were taking place again in some type of test tube, then as the reaction takes place, if you measure the temperature inside the test tube, you will notice that the temperature starts to fall because heat is being absorbed during the reaction. So this results in the temperature falling. So we say the temperature falls during the reaction. And the name given to this type of reaction is an endothermic reaction. So this refers to heat being taken in. Okay, so just before we finish, there's a special term which refers to these energy transfers during chemical reactions. And we say that the overall energy change in a reaction is called the enthalpy change. So this is a term you'll hear a lot in chemistry. Now, we're not going to define the term enthalpy in itself because that's a little bit beyond this course. But all you need to know is that the change in energy during the reaction is the change in enthalpy. And this, as I mentioned earlier, really refers to the change in heat during the reaction, okay, from our point of view. So the enthalpy change is represented by this term delta, which means change in, H, heat, change in heat. And when energy is released, that's to say we have an exothermic reaction, then the value of delta H will always be negative. So that's an important point. You've got to note that negative delta H means heat is being given out during the reaction. It means that temperatures will increase. Whereas if energy is being absorbed, its heat is being absorbed during the reaction, then we have an endothermic reaction, which means that delta H will be positive. Okay, so a positive delta H means heat's being absorbed, which means that the temperature of the surroundings will start to fall as energy is being absorbed. So in chemical reactions, these energy changes are often represented alongside the reaction, although in GCSE we don't tend to do that as a rule, but technically the enthalpy change should always be represented by the side of the reaction, as we have shown here. So this is a reaction that we'll be looking at in a later lesson. For example, the reaction of hydrogen with chlorine to produce hydrogen chloride gas, and the reaction of hydrogen with oxygen to produce water in the vapor state. And as you can see straight away, what's going on in these reactions is that energy is being released. We can see that straight away because the delta H is negative. And in the case of the reaction with hydrogen and oxygen, the same, delta H is negative. Also, you will note straight away that the energy released during the reaction between hydrogen and oxygen is much greater than the reaction with hydrogen and chlorine. So that is a much more exothermic reaction, and in fact, as you well know, it's quite an explosive reaction because it is the release of this large amount of energy that produces the famous in the pop test when we test for hydrogen in a test tube. Okay, that's a result of this energy being released during the reaction. So these are exothermic reactions, examples, which we shall look at in the following lessons, and endothermic reactions are harder to find. So most chemical reactions tend to be exothermic, they release heat, but an example of an endothermic reaction, which is the classic example, is that of ethanoic acid with sodium carbonate, or you could also use baking powder, and if you mix those two together in a beaker, you will get sodium ethanoate, carbon dioxide released through effervescence and water, and you will notice that the temperature of the contents of the beaker starts to fall as the two reactants absorb heat while they are reacting, and so this has a positive change in enthalpy. So the change in enthalpy in this case will be positive, and I am dreadfully sorry about this, but I have looked far and wide to actually get a figure for this value. I can't find it anywhere, so you might be able to help me and tell me what the change in enthalpy is for the reaction between basically vinegar and sodium carbonate, and I could, kind of perhaps write that down there at a later date. But that isn't important here. What is important is that this is an example of an endothermic reaction. Okay, so in the next lesson what we'll look at is the transfer of energy in terms of the chemical bonds that are involved. That's to say, in terms of the breaking and formation of chemical bonds as the reaction proceeds.